So this would be 24 and 2/7. Assuming I did my math right.
So it's negative 40 divided by 7.
Right, in this particular case, I mean, I'm using different numbers in the problem, but
Right.
it's final minus initial.
Okay. Do you want me to tell you what the decimal is for that? Negative 40 divided by 7?
Yes,
Negative 5.71. Maybe I'll do.
negative 5.71. All right, so we'll go that route. I'm just gonna make it 5.7 just to make life easier right now.
Okay, yeah.
Eventually, we're gonna- I'm
Whatever's
gonna-
easier for you, sorry.
I'm gonna set up the problem where we show that you're halfway in between. We can come up with somewhat of an educated guess, but then how you actually resolve the exact value.
Okay.
All right, so that becomes, so that was 5.7 rounded off, so that becomes 24.3. After 2 seconds, I'm gonna drop by another 5.7. So 18.6. After 3 seconds, I'm gonna drop by another 5.7, so that's 12.9. At 4 seconds, 7.2. At 5 seconds, 1.5. Okay. At 6 seconds, negative 4.2. All right, so I stop somewhere in between here. When I go from positive to negative, I have to stop in order to turn around. I know, looking at these two numbers right here, 0 is closer to this than it is to that. So I know that the time it actually stops has got to be somewhere closer to 5 than to 6. So whatever else I do, I'm going to come up with something closer to 5 than 6. Now, sometimes I give problems where it works out really nicely and you stop at some whole number here, or sometimes it's nicely halfway in between. For instance, if this had been 5 and negative 5, then, well, it stops smack dab in the middle. Obviously, this problem's not like this, and presumably that problem's not like it either. So, I go back to acceleration is the change in velocity over change in time. That formula that you used to find the acceleration. I know that this is negative 40 over 7, because that was already calculated. And I'm trying to find time. So I need to figure out the time it takes to go from 30 meters per second to 0. The acceleration is constant, so that ratio should still be the same. So this will be my final, which is 0 minus 30. That's the math problem we're now working with. Or negative 40 over 7 is equal to negative 30 over t. Well, I got two negatives there, so they can go away. Cross multiply, 40t is equal to 7 times 30. Divide by 40, divide by 40. T is equal to 1/4. Is 5.25. Wasn't expecting to work out to a rational number, but apparently it did. Of course it's a rational number, sorry about that. Well, it came between 5 and 6, and it's closer to 5. I'm feeling like something happened, right?
Is for acceleration, the change in velocity, is that just average velocity?
No, change.
Okay.
Going from some, you go from some initial value to some final value, just subtract final minus initial. Other questions? I guess first off, Brittany, is this good for you? Okay. Other questions? Okay.
No.
Oh. Elaine, is that you? You have a question? Maybe?
It'd be terrible to, number 10, maybe just don't.
So which one's that?
It's normal.
When speeding up, slowing down, and not changing speed. That goes back to when we were doing the plus minus zero. When our velocity, what happens when the velocity and acceleration are the same sign? And when they're opposite signs? So that's the key to that problem. I think I gave position in there also. That's just useless information for that problem.
That's what gets me.
That, okay. I think Amina, then Brianna.
4.
4. Let's see, 2 metal balls, same side, different weights, they drop. I'm ignoring air resistance here. But if I take 2 objects, now, obviously, not the same size, but I take 2 objects here, this weighs twice as much as this does. If I drop them at the same time, which hits first? So that, I think that's the essence of that problem.
Yes, is the,
Okay, do I drop one the second before the other one? And drop the heavier one?
is the.
Alright. 1001. So, because they're gonna fall at the same rate, they fall with the same acceleration, their velocity changes the same. If I drop one first, then this one will be playing catch up.
That's our first question, isn't it? Because they catch up with each other when they hit the ground, so it's how it told the building, right?
Yeah, so.
Was asked when they catch up with each other?
So you're saying 100 meters is what you're going with?
Yeah, because they have to hit the ground, so that's when they catch up with each other.
Yeah, agreed. That, because the building is 100 meters tall, if I drop it from 100 meters, then B is gonna hit the ground and stop, and then A will catch up at that point.
So it doesn't catch up.
It doesn't catch up in the air, it catches up once
They
you
hit
get,
the ground.
they hit the ground. I'm trying to remember what I've done in the past, I think I've accepted 2 answers for that one, that it doesn't catch up for 100 meters when they both get to the ground.
So
We'll just make it official, I'll accept either.
Oh, that's hard.
And, Rihanna,
Back to question 10.
which one?
Question 10, what you
10?
asked about.
Okay.
There's 2 answers that have the same sign and 2 answers that have different signs. So how do you figure it out from there? Like,
Well, there's-
without looking at the sign?
There are 2 answers. I mean, a blank could have 2 answers in it. Each case should appear once in one of the, in other words, A, B, C, and D should show up over here.
Okay, so they all.
Yeah,
okay.
so each of those shows up in at least one, shows up in one spot. In other words, don't put A in more than one spot, but I could have more than one answer in each of the blanks. If it's not in the process of changing speed. So all these, So velocity is speed and direction. If acceleration is positive, if it's a one-dimensional problem, if acceleration is positive and velocity is positive, it's speeding up. It's like getting pushed in the direction you're moving. If they're opposite signs, they're going against each other. But if velocity is not changing at all, in other words, change in velocity is zero, equilibrium, acceleration is zero. So the question is, for that last one is, in which situations is the velocity, not in the process of changing velocity, what that would have to be when acceleration is zero. And if none of them are that, then just put NA or put a slash through it or something else. Indicate there's no answer that goes there. Other questions right now? All right, let's take a 10-minute break. We'll reconvene here.